Here we're going to take a look at the intermediate value theorem. This theorem plays an important role in many mathematical theorems, in particular the mean value theorem for integrals and the second fundamental theorem of calculus, which we will get to later. So the theorem reads as follows. We let f of x be a continuous function over a closed interval a, b. If d is any number chosen between f of a and f of b, then there is a number c between a and b in which f of c equals d. So that's the statement of the theorem. Let's take a look at the graphic down here which will illustrate it. So here we have the graph of a function. Right here is a and b on the x-axis, f of a and f of b on the y-axis. So notice that my graph starts here at a f of b and it goes up to, a f of a, starts at a f of a and goes up to b f of b right here. It's continuous, so it has no breaks. Now, the intermediate value theorem makes this statement. If you're given any number d between f of a and f of b, then you can find a c between a and b in which f of c equals d. Now notice, if I move the slider down to that d value, notice that how if you continue the red dotted line across, you will eventually hit the graph. And then you drop down, right there's your c value. So f of c equals d. And that's true no matter where I put the d between f of a and f of b. So the fact is, no matter where I put that d, I will always be able to continue that the line across and hit the graph somewhere. And the reason you hit the graph, the reason you're guaranteed of hitting the graph is because it is continuous. The continuity of the function f is critical for this theorem to hold true. Let's take a look at an example that shows why that continuity is so critical. If we consider this graph down here, so here we have the graph of a function from a to b, and notice that this function is not continuous because of this break right here. Right here is f of a on the y-axis, here is f of b. Now notice that we can strategically pick some value d between f of a and f of b such that when we extend a horizontal line across, we never touch the graph of the function. And so that means that there is not going to be a c value down here in which f of c equals d. And so that's why you need continuity in the statement of the intermediate value theorem. Let's take a look at an example. So here we want to use the intermediate value theorem to show that this equation, negative x cubed minus 2x plus 1 equals 0, has a solution somewhere in the interval from negative 1 to 1. So now our function that we're going to be working with is going to be the negative x cubed minus 2x plus 1. Now, the a and the b that's referred to in the intermediate value theorem are going to be the negative 1 and 1. So a is going to be negative 1. The b is going to be 1. And also note one other thing. This polynomial here, it is a polynomial, so therefore it is continuous everywhere. Right? So this function is continuous everywhere, so it is continuous on the interval from negative 1 to 1. All right, now let's look at f of a and f of b. So f of negative 1. Okay, if I put negative 1 in here for x, I'm going to get minus negative 1 minus negative 2 plus 1, that's going to be 4. And f of 1, that's going to be negative 1 minus 2 plus 1, that's going to be negative 2. All right. Now notice here we want to solve this for where it's equaling 0. So that's going to be the d value. So the d is equal to 0 in this case. And so notice also that the 0 is between negative 2 and 4. So note 0 is between 4 and negative 2. And so, therefore, by the intermediate value theorem, we know that there will exist a c between negative 1 and 1. So there is a c value between 1 and negative 1 in which f of c is equal to 0. In other words, negative c cubed minus 2c plus 1 equals 0. All right, and we've proven that a c exists. Now notice we didn't actually find what c is equal to. We only proved it existed. The intermediate value theorem does not tell us how to solve for the c. It only proves the existence of the c. That's all we know, is that there is a c somewhere between negative 1 and 1 that satisfies this equation. All right, let's take a look at graphically what is going on here. So here we have the graph down here. Now here is the graph of our function. So that's the graph of y equals negative x cubed minus 2x plus 1. Now let's notice right here is a, right here is b, right here and here are the f of b and f of a. Now the d is the value 0. That's right here. Notice it is between f of a and f of b, so that's the d. Notice that if we extend the horizontal line over, we will hit the graph somewhere, because the graph is continuous, the function is continuous, and right there is the c value on the x-axis in which f of c is equal to 0. And that's what's going on graphically. All right, so that concludes our discussion of the intermediate value theorem.